Hello everyone, hope you all are doing well. So today we are going to discuss the next question of our agriculture optional answer writing practice series, and today's question is define water stress and discuss the effects of water stress on anatomical and physiological changes in plant growth, and also discuss soil and weather based plant water stress indicators. So this question was asked in last year's agriculture optional paper of UPSC Civil Services examination, that is in 2024. So we will see how we can approach this answer, and after watching this video you will be able to write these answers very nicely. So when you see the question is actually divided into three parts. First part, although a small part, that we have to just define what water stress is. In the second part, we have to discuss the effects of water stress on anatomical and physiological changes. That is simply we have to discuss the anatomical and physiological changes seen in plant due to water stress. And then in the third part, we have to discuss the soil and weather based plant water stress indicators. So how we can use soil and weather to as an indicator for water stress for plant. So this is how we can uh, divide the question in three parts. So let's start. So the first part, we have to define what water stress is. So water stress is a situation when the demand of water exceeds the available supply. When is a situation when demand of water demand of water succeeds the, or you can say exceeds the, demand of water exceeds the available supply or supply of water. That is, in case of a plant, suppose the plant needs 100 liters of water for its normal growth. But what happens, the demand is 100 liter, but the actual supply we are getting is just of 50 liter. So what the situation will arise here? The situation of water stress will arise here. That is, the plant is not able to get its demand, not able to fulfill its demand through this supply. So this is what water stress is. And there are various reasons for water stress in the current scenario. First of all, we all know decreasing groundwater availability, climate change is other problem, pollution is other problem. So all these we all know what are the general problems of water stress. Drought, generally all these things happen due to, currently it is happening due to climate change, pollution, and uh, high use of water. And due to high use of water in current scenario, we are going to face water stress in the future. And already there are various reports which say that majority of the globe, that is around 50% of the world population, is going to water stress. So obviously if the population is going to face, then the crops, the agriculture will also face water stress situations. That is why this question was asked. So I hope you understand what a water stress is. Now you will be able to define it. Now let's move to the second part of the question, that is anatomical and physiological changes in plant growth due to water stress. So first of all, we will discuss the anatomical changes. Anatomical changes. So first change you can see in leaf morphology. Leaf morphology. So what changes can you see in leaf morphology? Obviously, first of all, the leaf size will be reduced. Reduced leaf size to reduce evaporation loss, obviously. Then you will see the cuticle will become thicker cuticle. So, or you can say cuticle is a kind of waxy layering. Okay. So again, it is for to reduce water evaporation. Next, we will say stomatal density and size will decrease. Okay, they will reduce of stomatal size and density. It is again to reduce evaporation. In some plants, you will see that the leaf size are reduced so much that they are seen as such as thorns. So many plants, those thorns are leaves only. So these are the changes you will be able to see in leaf morphology. And if the plant is facing high water stress, you will see that the leaf will start curling and wilting. Leaf curling and wilting. So these are the changes related to leaf. I hope you all understand this. Secondly, we will see the changes in root system, changes in root. In root, you will see that the root elongation will be more. That is, the roots will be deeper, deep roots, deep and elongated roots. That is, suppose this is soil, the root will go deeper and deeper into soil to search water. Secondly, root to shoot ratio will increase. Root to shoot ratio will increase. That is, you will see that the roots is very deep and the shoot is very small upper. So you will see that the ratio of root to shoot will increase, and that is all because of the water scarcity and to conserve water. You will also see changes in xylem tissue alterations. You will see xylem vessel adjustments. Let me look some part. I hope you understand the leaf morphology. You will see changes in xylem vessel adjustments. You will see changes in xylem. So what happens in xylem? First of all, the xylem vessel will enlargement of xylem vessels. So what will happen here? The xylem vessel will enlarge to facilitate more water transport. Okay. Suppose this is the general vessel, xylem vessel in normal days. In water stress, it will enlarge so that the water uh, going through this xylem will increase. Okay. So this is one thing you will see. Secondly, we will see that the xylem tissue alteration. Xylem. This is not related to this. Xylem tissue alteration, you will see that the lignin content is increased that can help to strengthen the xylem vessel to cope with reduced water flow. That is thickening of lignin, or you can say the increase in lignin content, so that it can cope with the reduced water flow. So these are some of the anatomical changes we can observe in the plants during water stress. Secondly, we will also discuss physiological changes. Physiological changes are asked in the question only. So what will be the physiological changes? Obviously, first of all, you will see stomatal closure, so that the water loss is prevented. Reduced photosynthesis can be seen, so that the evaporation loss, or you can say transpiration loss of the plants can be prevented. Secondly, obviously, there will be stomatal closure, so there will be reduced transpiration. There will be osmotic adjustments in the plant. Osmotic adjustments, that is, various kinds of osmolytes will accumulate, such as sugars, amino acids, so that the osmotic potential of cell is maintained. Various kind of osmolytes, such as sugar, amino acids, all these things will accumulate so that the plant do not suffer some osmotic imbalances. Okay, so these things will we see. There will be altered hormonal balance. You will see that the stress hormone, which is abscisic acid, which is normally known as ABA. This is abscisic acid. Abscisic acid. So it will increase because it is stress hormone. It will reduce transpiration. You will see that the root polarization, which I've discussed above only, and hydraulic conductivity of the roots will increase. Okay, increase hydraulic conductivity of roots, so that the roots can absorb lot amount of water from soil. So these are the physiological changes we can see the plants, and overall in long term effects of this changes will be see that there will be growth retardation, there will be slow growth in the plant, the problems of senescence can be seen. That is, the plant will go into some process where it will reduce its metabolic activities and other things. So these are the long term effects which can be seen. So I hope you understand the physiological and anatomical and physiological changes in plants. So this was the part 2 of the question which is done. I hope you understand it. Now third part of the question is whether and soil and weather based indicators of stress. So first of all we will discuss the soil based indicators. So what could be the soil based indicators? Obviously we will have to measure soil moisture content. Soil moisture content can be measured by using various devices such as volumetric water content. We will measure volumetric water content. We will measure soil water tension. Soil water tension. So by measuring this, we will get to know about the amount of water present in the soil, and we can go for the stress. Secondly, we can measure the soil water holding capacity. Soil water holding capacity. Here we will see that filled capacity of soil is what is wilting point. So all these things will help us to understand about stress. We will measure the soil temperature. It is generally seen that when there is water stress in plants, the temperature will be high because there will be lack of water, and there will be no problems of water stress, then the temperature will low. So if temperature is increasing rapidly and more than the average margins, then you can see that the water is replacing. So soil temperature can be measured. Secondly, we can measure root zone depletion, because it doesn't matter how much of water is present in soil. It is important that the root zones should have enough amount of water, because the root of the plants absorbs water from this zone also. So we will observe it in this zone, the moisture content in this zone. So these are some of soil based indicators. By measuring these things in the soil, we can predict that what is the amount of water in the soil and what is the status of water stress. Secondly, there are these weather based indicators also. Weather based indicators, obviously first of all we will measure precipitation. Suppose in a year there is a very low precipitation, obviously we can go and observe that the water stress will be there, that is rainfall defects will be there, low rainfall is one problem. Secondly, we will go for temperature. If the temperature will be higher, obviously the evaporation will be higher and there will be stress in the soil, or you can say water stress will be there, or it is also known as thermal stress. That is, due to high temperature, there is huge evaporation and leading to water stress. We will check for relative humidity. That is, if the relative humidity will be lower, if relative humidity is lower, obviously there will be more evaporation leading to water stress. So we can check it. We will check wind speed. If there are dry winds at higher speed, obviously water stress will be, evaporation will be more and there will be water stress. We will check for evapotranspiration. If we can check for evapotranspiration, we can go for various drought indices such as one we have Palmer drought severity index. Palmer drought severity index. One index is more, there is standardized precipitation index. Standardized precipitation index. So all these index can be helpful in measuring the drought. We can measure the GDD, that is growing degree days. So it we can measure the amount of growth as per temperature here. That is, higher value of GDT often leads to more water consumption of plant. If the GDT is higher, then we can see that the water consumption in the plants will be also higher. So through this we can measure for water stress. So these are some of the water based, or sorry, these are some of the weather based techniques through which we can indicate, through which you can measure water in stress, or these are the indicators of weather based water stress measurement. So I hope you understand the both indicators, and at the end you can conclude that I think combination of both these two indicators should be used for better understanding of water stress. And although you can conclude about water stress, how water stress is creating a lot of problem, you can add some government initiatives in your conclusion, how such as Pradhan Mantri Krishi Sinchai Yojana, per crop mold drop, all these things, how can solve the problems of water stress. So that will be better conclusion there. So this was today's question. I hope you understand all the parts of the question. So that is all for today. If you like it, please press the like button. Please do share and please do subscribe. It takes a lot of hard work to make such videos for you on regular basis. And if you like, if you share, if you subscribe, it motivates us to make more such videos for you regularly. So that is all for today. Have a nice day. Thank you.